I'm going to go through this problem one more time just in case, because it seems like few people were just looking at me like I was a little cray-cray today. So I'm going to draw this tank. We've got a 10-foot tank with a radius of 5 feet. And it says water's running into the tank at a rate, that's the magic word for a derivative, and it was 9 cubic feet per minute. Now, cubic feet is volume, so I know it's a dVdt. It's saying it's running into the tank, so the volume is increasing, so I know that has to be positive. The tank stands point down and has a height and a base. Okay, we did that. How fast is the water level rising? Okay, so now I need water. So I need my blue pen for water. That's the water. The water's height, we're going to say h because it's changing. And the water's radius, we're going to call r because, again, it's changing. Now, it's really important to see that cone is similar to the big cone. And even another way to say that would be that right triangle, that little right triangle, is similar to this smaller right triangle. We know that r over h is equal to 5 over 10. Always. That's always true. So in other words, if I cross multiply to solve that ratio, r to 5 is equal to h to 10, I get this guy. So my 2 times my radius is equal to my height. Now, we need the volume formula for a cone because we have a dVdt. So if I need to do dVdt, I need the volume formula for a cone. This is the volume formula for a cone. All right. You can either sub right in with your r, right in, your h that you solve for down here or not. You could also solve for r. Dan suggested doing that because if I put in r is h over 2, then my whole thing is in h. Why did he think that was important? The question was asking how fast the water level was rising. Water level is h. So the rate, how fast is rate? The h dt is what we're looking for. I'm thinking I don't want to do that because I don't want the fractions in there, but honestly it doesn't matter. Plus, it seems easier to solve to me, so I probably would have done that without thinking, but you can absolutely do that. But anyway, I'm going to go ahead and put h in and get 2r. So when I multiply my volume, I get 2 pi r cubed divided by 3. All right, so now I can, sorry, I had a little mishap there. I can take my derivative and get my dVdt. dVdt is 2. When you multiply the 3 times the divide by 3, it's going to cancel. Pi r squared, because when I brought the 3 down and multiplied it, canceled that 3 out, times dr dt. Don't forget the dr dt. We're not used to having to do that on this side of the equation, but we're taking the derivative with respect to a variable that this isn't, so you have to. All right, now, we know the radius at that moment in time. We can figure that out. We don't have it. We have the height at that moment in time is 6 feet deep. So if we put in 6 feet for the height, we get radius equals 3 when h equals 6. So now we're going to substitute in. We get dVdt is 9. We get 2 pi r cubed, well, r squared, excuse me. That's 9. And dr dt is not what we're looking for, but it will help us find what we need. All right, I've got to move this up. It's going to jump a little bit. All right, so now, let me change colors. These 9s are going to cancel right out. And I'm going to get 1 divided by 2 pi, because this 9, when it cancels, it's a 1, equals dr dt. Now, I don't want dr dt. It didn't ask me for dr dt. We're supposed to find dh dt. So I have to go over here and relate dr and dh. And again, I prefer this to the fractions because I don't want to take the derivatives of the fractions. I think it's easier like this. You have to take this derivative of this secondary formula, just kind of like what we did with optimization. We had to we had to use the other formula. Well, you're going to have to here too. Well, the HDT is the RDT times 2. So I need to take this puppy and multiply it by 2. Okay, so I have to do 2 times 1 over pi. That's going to give me my DHDT. Okay, because that's how I get DHDT. Boom, right there. So my answer is 1 over pi equals DHDT. Now, I am assuming the last time you told somebody that the height is changing at 1 over pi rate something per minute, you'd be like, what the heck is she talking about? So that doesn't make a whole lot of sense. Convert that to a decimal. Okay, sorry I had to move that again, but that is 0.32. If you're doing AP, 0.318. But I'm going to round it because who's going to measure out further than that? Feet per minute for DHDT. So your height is changing at a third of a foot approximately per minute. If you're confused on how to get your units, look at what your derivative D tells you. Your deltas, your differentials, those are called actually. H is a height, that's measured in feet. T is a time. In this problem, that's measured in minutes. So that's how I got these. And use these DHDT, DVDT to help you figure out what the units are. They're the same units as what you get here. So that will help you. All right, I hope that cleared that up a little bit if you were confused in class today.